Welcome to the 15th video lecture of Class 9 Science. We are dealing with our second unit, that is motion. So in this video lecture, we will be learning about the uniform circular motion, centripetal acceleration and centripetal force. So before going into the new topics, let us recall the things which we have learned in the past 3 video lectures. So first we learned the three equations of motion, that is v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, whereas where v refers to the final velocity, u refers to the initial velocity, a refers to the acceleration, t refers to the time taken, and s refers to the displacement. Okay. After learning the three equations of motion, which actually connects the different concepts of motion, we solved some of the numericals, and after that we learned in the previous lecture regarding the acceleration due to gravity, which is represented by small letter g. On earth it is 9.8 meter per second square, or we can sometimes consider it as 10 meter per second square. Okay, so this is the constant acceleration a body or an object gains when it is freely falling from any height. Okay, after that we studied even about the motion of freely falling body, where we considered the gravity, the acceleration due to gravity will be always towards the earth, that is downwards. So any object which is moving upwards, in that case we will take the acceleration as minus g. Is there any object which is falling freely, then we take the acceleration as plus g, and using these we took the help of equations of motion and we calculated the asked quantity in the case of motion of a freely falling body. Okay, I hope you went through those 4 or 3 video lectures where we discussed about the equations of motion and their importance, some numericals, and freely falling body. So in this chapter, as I said, we'll be learning about centripetal force, centripetal acceleration, and the uniform circular motion. Okay, so as we did in the last class, now also we'll do one small activity. If it is not possible, it's okay. I know that all of you must have done this at any one point of time. So it is a very simple activity. Take a piece of thread and tie a small piece of stone at one of its ends. Rotate the stone to describe a circular path with constant speed by holding the thread at the other end, like the guy is doing in this picture. Okay, so I am sure that all of you have done this even at once, right? Okay, so now if you release the thread, now you're leaving the thread, you're holding some thread and you're rotating the stone, right? Now if you leave the thread, can you tell the direction in which the stone moves after it is released? In which direction the stone will be moving after you leave that thread? So that is the question. Okay, think upon it. Because no need to do this activity now also, because you are familiar with this activity, right? So whenever it is anything which is like a thread or something or a key bunch, you tend to do this, right? For example, especially with a key bunch and all, so you try to rotate it as the guy is rotating the thread with the stone. So once you leave it, or if it slips from your hand when you're rotating the key bunch or any thread which is tied to a stone, in which direction it will be moving? So that's the question. Okay, so on being released, the stone moves along a straight line. Everybody have observed it. I hope everyone have observed it, that once you leave it, it will not be moving in a circular path. Before releasing, when you are rotating it, it will be rotating in a circular path. Once you leave it, it will not be taking any circular path. It will be moving in a straight line. Yes, it will be moving in a straight line tangential to the circular path. I hope you people are clear with the concept of tangent. So it will be moving along the tangent to the circular path. So this is because once the stone is released, it continues to move along the direction it has been moving at that instant. So this shows that the direction of motion changes at every point when the stone was moving along the circular path. So as you can see clearly in the picture, it represents the motion of the stone which you was rotating using the thread. So this shows that the direction of motion at every point. So you can see the blue color arrow mark is changing its direction at every point on this circular path. Okay, but the velocity may be same, the magnitude of the velocity may be same, but the direction of the velocity is changing at every point of time on the circular path. When an object is moving with a constant speed along a circular path, the velocity changes due to the change in its direction. We have learned that velocity is a vector quantity. That means it has got both magnitude and direction. So if any one of them, either the magnitude or the direction, if it changes, then we say that the velocity is changing. Like in this case, the magnitude is constant, maybe like 3 meter per second or 3 meter per minute. It may be like that. So it is constant at every point of time. The magnitude of the velocity is constant, but the direction of the velocity is changing continuously at every point on this circular path. So we say that there is a change in velocity. So when there is a change in velocity, such motion is called as an accelerated motion. This kind of an accelerated motion can be observed in so many situations like revolution of earth around the sun, revolution of moon around the earth, and the tip of the seconds hand of the clock are all accelerated motions. Okay, so here the magnitude is uniform, but the direction of the velocity changes at every point of time on the circular path. As you can clearly see in this picture, see the blue color one represents the direction of the velocity, which is changing at every point, right? Now it is rightwards, now it is left, now it is down, and now it will be up, like that. At every point on the circular path, the velocity direction will be changing even though the magnitude is constant. Okay. So if an object is moving along a circular path of radius r, if the circular path which we have considered has a radius r, and a stone which is rotating or moving in the circular path takes t amount of time or t seconds of time in completing one rotation, that is to come back to its original or the starting position is nothing but one complete rotation, right? Then the speed v is given by speed. They are telling it as speed because speed here represents the magnitude of the velocity. We are not talking about the direction of the velocity, we are just calculating the magnitude, how much it is. We are not talking about in which direction it is. Okay, therefore instead of telling it as magnitude of velocity, we are writing here as speed but representing it with the small letter v. Okay, then the speed v is given by speed is equal to, we know that it will be always distance or displacement by time taken. Here displacement, since it is moving in a circular path, distance covered will be when it makes one complete rotation. the total distance traveled will be the circumference of the circle divided by the time taken. So the circumference is 2 pi r divided by the time taken, that is t. So this is the speed of the um, object moving in the circular path of radius r. Okay. Now we will look into two more concepts which are related to the same uniform circular motion. So even though there is a change in velocity, why we call it as uniform circular motion? Because there is some similarity, that is there is some uniformity in that motion also. That is, the velocity, the magnitude of the velocity will be always constant. Magnitude of the velocity, that is the speed, will be always same, always uniform, right? The previous case where we have rotated the stone using the thread, the velocity, that means the speed or the magnitude of the velocity was always same. So there lies the uniformity in that motion. Even though the direction is changing frequently, the magnitude is constant. Therefore we say it as, or call it as, uniformly or uniform circular motion. Okay, moving on. A body is said to be accelerated if the velocity of the body changes either in magnitude or in direction. So in this case, the magnitude is constant, the direction is changing, therefore we call it as a accelerated motion. So the motion of the stone in the circular path with constant speed and a constant change in direction is an accelerated motion. Yes. In this case, there must be an acceleration acting along the string directed inwards, which makes the stone to move in the circular path. So we saw that the stone is moving like this, right? So when it is moving like this, we said that there is an acceleration. So this acceleration is also a vector quantity. So if it is a vector quantity, we can calculate its magnitude very easily using the formula. But what will be its direction? We know that the direction of the velocity will be always tangential to the path, the circle, right, at that given point. So what will be the direction of this acceleration? So this acceleration, as you can see, will be always the blue color arrow mark, the blue color thing always shows the direction of acceleration. So the direction of acceleration, in this case it's changing, sorry for that, always it will be inwards. The bigger arrow you can see, one second, always it will be radially inwards. That means so this, the bigger arrow, that is the blue color line, it is also an arrow mark, right? So it will be always in that direction. So it is represented by AC. So the acceleration in this case will be always inwards towards the center. Okay, towards the center, because of which the stone will be always moving in the circular path. So this acceleration is known as centripetal acceleration, which is always acting inwards or along the radius. So when there is some acceleration, obviously there will be a force, and in this case the force is called as centripetal force, because this force is coming from the centripetal acceleration, therefore the force is called centripetal force. So here you can see the green color represents the direction of force. The arrow which is in green represents the direction of force. It is always remember, the force will be always along the direction of acceleration. Always the force will be in the direction of acceleration. So we said that acceleration will be always along the radius towards the center, right? So here you can clearly see how exactly the force also will be acting in this case. The red color arrow mark shows the direction of velocity, the green color arrow mark shows the direction of force as well as the direction of acceleration. So this force is called as centripetal force and the acceleration is called as centripetal acceleration. Okay, so how actually we calculate this? Let us see. The centripetal acceleration is directed radially towards the center of the circle. The centripetal force must act on the object radially towards the center. That means the direction of acceleration, that is centripetal acceleration as well as centripetal force, will be always towards the center. Let us consider an object of mass m. For example, the stone which you was rotating has got a mass m moving along a circular path of radius r with a velocity v. Its centripetal acceleration is given by A is equal to v square by r. How actually we calculate the acceleration? V square by r, that is square of the velocity divided by the radius of the circular path will give you the centripetal acceleration. Remember, this is not the acceleration which we learnt in the case of linear motion. So all in the previous things, whatever we learnt, it was always along a straight line. Whether it is a freely falling body or a car moving, everything we studied keeping in mind the motion is always linear or along a straight line. Here it is different, that is centripetal force or the centripetal acceleration or a circular motion we are talking about. So A is calculated as v square divided by r. R here is the value of radius of that circular path. Just remember, whenever there is r, that means the radius coming into picture, you should always be clear that this question is with respect to the circular motion. Don't get confused with the man who is running in the field and he completes one rotation and what will be his displacement. In that case, the displacement will be 0. Okay, don't get confused with that and this. Okay, the magnitude of the centripetal force is given by okay, so let me clear that with this. So in the previous case, when I told you about the man running in the ground where he is traveling or walking or jogging in a circular path, we don't come up with a centripetal force or the centripetal acceleration. Why? Because the man is not tied or not attracted towards the center of that circular path. See, in the case of the stone, there is a thread which is connecting the center and the stone. Even in the case of moon rotating around the earth, there is a gravitational force which is actually attracting the moon towards the center. Even in the case of earth rotating to around the revolving, not rotating, revolving around the sun, there is a gravitational pull which is causing the earth to move in a circular path, almost a circular path or an elliptical path. So there is something which is pulling them towards the center or pulling them towards the center. But in the case of a man who is just running in a circular path, there is no pull or a push from the center of that circular path. Okay, there are two different scenarios. In that case, the man is moving freely, right? Okay, on the surface of earth he is moving freely. With respect to the circular path which he is covering, he is moving freely. But in this case, the stone or the earth or the moon, they're not freely moving in a circular path. They are moving because they are held by some force at the center. Okay, so this is the difference. Okay, the magnitude of the centripetal force, the magnitude of the centripetal acceleration is given as v square by r, whereas the magnitude of the centripetal force is given by Force is always mass into acceleration. Here, since we are talking about the centripetal force, it is coming from the centripetal acceleration. Therefore, instead of just taking acceleration, here we will be taking it as mass into centripetal acceleration. So it is m into v square by r, that is mv square by r. Okay, so this is how we calculate the centripetal acceleration, centripetal force, and in the previous thing we even calculated the speed of the object which is moving in the circular path. Okay, so let us solve a small problem using these concepts. A 900 kg car moving at 10 meter per second takes a turn around a circle with a radius of 25 meter. Okay, determine the acceleration and the net force acting upon the car. Okay, so the mass of the car is given, the velocity of the car is given, the radius of the circular path is also given. So what we are asked to calculate, they are asking us to calculate the acceleration and the net force. So here it is a question of centripetal acceleration and the centripetal force. Therefore mass m is equal to 900 kg. The velocity is equal to 10 meter per second. Radius r is equal to 25 meter. We are asked to calculate centripetal acceleration A and the centripetal force F. So it is quite simple. We have just learned it. The acceleration is equal to v square by r, that is centripetal acceleration. So v square, it will be 10 square divided by 25. 10 square is 100 divided by 25. So it will be 4 meter per second square. The centripetal acceleration will be 4 meter per square. Net force acting upon the car. F is equal to ma. M is 900 and A is 4. So it will be 900 into 4. Therefore the total force or the net force is equal to 3600 newtons. So the centripetal acceleration is 4 meter per second square and the centripetal force is 3600 newtons. So this was about your second unit. I hope I have covered all the concepts given in the second unit, and some of the important problems also have solved. So remaining exercise I ask you to do on your own, because all the important questions regarding it, especially the numericals related to equations of motion and the circular motion. Circular motion, one problem I have solved and the rest are easy. So I want you to do those problems on your own. So rest are the theoretical questions which you can learn, or using your textbook you can write down in your notebook. So that's it regarding the second unit, and we will be starting the next unit in the next video lecture. Thank you. Have a good day.